Okay, a quick example here. Let's evaluate these limits. Now that we know our direct substitution rule, this is our golden rule when it comes to limits. So the first thing we want to do is sub in whatever x value it's approaching. So here we're going to sub in x equals 3 and see if we get something that makes sense. So we have 2 times 3 squared plus 1, all divided by x, which is 3. This is going to give us a number. This number is going to be 18 plus 1 over 3, which is 19 over 3. It's not the prettiest number, it's some weird fraction, but it's a finite number. So the limit exists, and this is the value of the limit. That's it. Okay, we don't have to graph it. Okay, let's take a look at this next one. So again, do the same thing. Do a direct substitution. Whenever there's an x, sub in a negative 2. So here we have the square root of 3 times, instead of x, it's now negative 2, plus 8. This is going to give us a square root of 2, which is a finite number. So this is the limit. That's it. How about with absolute values? Do the exact same thing. Whenever there's an x, I'm going to sub in negative 3. So I get absolute value of negative 3 squared plus negative 3 minus 10. Simplify, take your time, especially with the positive and negatives. You're going to get 9 minus 3 minus 10, which is the absolute value of negative 4. Now, absolute values are super nice. They actually turn anything into a positive. So this guy turns it into a positive 4. Part D, our last one, and it's a little tricky. I'm giving you a warning here. If we do a direct substitution, we're subbing in x equals 1. We'll end up with the square root of 1 minus 1, which is the square root of 0. Now, a lot of students would say, oh, square root of 0 is 0, done, bam, that's the limit. Don't do that. Remember, whenever you end up with square root of 0, you want to split it up into the left-hand limit and the right-hand limit, and then see if the limit actually does exist. So let's go ahead and do that. So if I'm subbing in x approaches 1 from the left, I'm thinking something like 0.9999, something really close to 1 from the left. Okay, so this is 1 from the left minus 1. Well, 0.99999, something just shy of 1, minus 1, is going to give me something small, but negative. Now, can I find the square root of a negative number? No, that is undefined. So since one of these limits don't exist, the whole limit does not exist. So therefore, this guy does not exist. And just for completion's sake, let's find the right-hand limit. When x is approaching 1 from the right, I'm thinking about 1.000001, something really small like that. And that's going to give me the square root of 1 from the right minus 1, which is going to give me 0, but a slightly positive 0. And that's going to be 0. So one of the limits from the left is undefined. One of the limits, which is from the right, is 0. That's why the whole limit does not exist. Now let's take a look at part E, which is a piecewise function. So part 1, we want to find the limit as x approaches negative 1. So negative 1, is that in piece 1 or is that in piece 2? Negative 1 is less than 0, so we're in piece 1 over here. So do a direct substitution. I'm subbing in negative 1 for x. This is going to give me the absolute value of negative 1, which is 1. This is a finite number, 1, so this is the limit. That's it. Now let's look at part 2. In part 2, we are looking at the limit as x approaches positive 1. Well, that's going to be in the second piece because positive 1 is greater or equal to 0. So I'm looking at this guy here. So do a direct substitution. Whenever I see an x, I'm going to sub in a 1. So I have 2x squared minus 1, which is the number 1. That's finite, so the limit exists and equals 1. Now let's see what happens when we try to find the limit as x approaches 0. So x approaches 0 in this piecewise function is the connecting point between these two pieces. So we have to find the left and right hand limit. So limit as x approaches 0 from the left I have the function absolute value of x. And then the limit as x approaches 0 from the right I have this quadratic. And now let's do our direct substitution. I'm going to get a 0 from the left, and I'm going to get a 2 times 0 squared minus 1, which is negative 1 from the right. Since both of these limits don't equal, they both exist, but they don't equal, then I know that this whole limit does not exist. The limit as x approaches 0 in general of the function does not exist.